Alright, actually I changed my mind here about how I want to explain this here. So forget about this for a second. But again, we have moles per liter times seconds divided by moles squared over liter squared. So instead of dividing by that, we can think of it as multiplying it by the reciprocal. So we're going to have liter squared over mole squared. And so now we can cancel out what is going to work. So moles and one of these moles will cancel out. Liters with one of these liters cancels out. And so we're left with a situation where our units are liters per seconds times mole. And so that's going to be what our units are. Liters seconds times moles. Okay, and then so for part E, now that we have the K, the constant there, and with units and everything, it's asking us to find the initial rate. In this case, we have our initial concentration of A, our initial concentration of B, and we have our K. So just plugging these into our rate equation will give us the rate for that situation. So rate is going to be equal to, again, concentration A isn't part of our kinetics expression here, but we have the 0.233 squared times our K. I should have put earlier there, which was 0.577. And as you notice, I'm not really keeping track of the units right now because what we used this expression to figure out the units, and so if we do it the other way around, the units will come out to the same thing with our initial reaction rate. So that'll just save us a little bit of time. So in that case, our rate comes out to 3.13 times 10 negative 2 moles per liter times second. Okay, and so we have that, and then they give us a proposed mechanism for the reaction, and it asks us to provide two reasons why it's acceptable. And so anytime they give us a mechanism, they're looking for two things to see if it's acceptable. First of all, if we add up the two steps of the reaction, it needs to come out to the same thing as the overall reaction. And so in this case, we have two B's on the left side, one on the right, so we end up with one on the left in our final product. An E on the left and E on the right that cancel out. One A on the left that stays there. So A plus B gives us C plus D. Okay, so that part is consistent with our overall equation. The other thing they're looking for is if the rate limiting step, so the slow step, is going to be consistent with our rate law. And so in that case, remember the rate, the molecularity, as it's called, of the rate limiting step should be the same as our kinetics. So that means since in our rate expression, since it was second order with B, zero order with A, that we should have a coefficient of 2 for the B reactant in the rate limiting step, which is true here. So in this rate limiting step we have B and we should not have A, and we don't. So both of those reasons show why that's acceptable. Okay, and so for the last part, it's asking us about another species. It's not in our overall reaction, but species E here. Asks if it's a catalyst or an intermediate. And so this is kind of just remembering which one, what the difference between the two is. A catalyst is something that you start with. So it's something that's a reactant in a way. You start with it, but then you use it up in the process, but then you produce it again in the end. So you start with it, but you also finish with it. Whereas an intermediate, you don't start with, it shows up in the second part of the step, but then you use it up before the reaction is complete. And so you can see based on these definitions that E is in fact an intermediate and not a catalyst.